Good day, the topic is total pressure if fluid is above and below the curved surface. For the analysis, apply the combined components method of above and below the curved surface. For our sample problem, in the figure shown, the 1.2 meter diameter cylinder, 1.2 meter long, is acted upon by water on the left, and oil having specific gravity of 0.8 on the right. Determine the components of the reaction at A if the cylinder weighs 19.62 kilonewtons. First, for horizontal component of the reaction at A. Note, regardless of the case, same analysis for above and below for horizontal component. So just consider the two-dimensional vertical plane surface. Consider FBD of the system and assume direction of the reactions at A to the left since water has higher elevation and higher specific gravity than oil. Apply some forces horizontal equal to 0, due left equal to due right forces. The forces due left are A sub H and F sub HO, while due right is F sub HW. Rearrange for unknown A sub H, transpose F sub HO at the other side. For the horizontal component for liquid water, F sub HW, F sub HW is gamma of water times H bar times A. Substitute gamma of water as 9.81 kilonewtons per cubic meter, H bar as 1.2 meter, and area as 1.2 by 1.2 meter. Therefore, F sub HW is 16.952 kilonewtons due right. For the horizontal component for liquid oil, F sub HO is equal to gamma of oil times H bar times A. But gamma of oil is specific gravity of oil times the unit weight of reference fluid, that is water. Substitute S sub O as 0.8, gamma of water as 9.81 kilonewtons per cubic meter, H bar as 0.6 meter, and area as 1.2 by 1.2 meter. Therefore, F sub HO is 6.781 kilonewtons due left. Substitute identified external horizontal forces due to liquids, water, and oil. Therefore, the horizontal reaction at A is 10.171 kilonewtons and is due left, which means positive. That is correct assumed direction. So for the next, let us consider the vertical component of the reaction at A. Note, consider exposure of the surface of the cylinder in quarters. Consider the FBD of the system and assume upward direction of the reaction at A. Apply some forces vertical equal to 0. Upward equal downward forces. Upward forces are A sub V, F sub V, W, B, which means it is from below, and F sub V, O, the oil, B, which is below. While downward forces are F sub V, W, B, A, rather, which is above, plus W, which is the weight, and F sub V, O, A, which is for oil, that is above. Rearrange for unknown A sub V. For F sub V, W, A, or above for water, it is equal to gamma of water times V. But for volume, we need to determine only the fluid above the surface. Thus, consider one rectangle or rectangular prism, then subtract quarter of a circle prism. Therefore, for our F sub VWA, it is equal to gamma of water times the quantity, the rectangular area minus the quarter circle area, then multiply to the length L. So substitute gamma of water as 9.81 kilonewtons per cubic meter. Area of gross, that is the rectangle, which is 0.6 by 1.2 meter. For area of quarter circle as pi times radius, that is 0.6 meter raised to 2, then divided by 4. And length of cylinder as 1.2 meter. F sub VWA is 5.147 kilonewtons downward. Update the equation with value of FVWA. Next, for FVOA, it is equal to gamma of oil times the volume. But the volume we need is for the fluid that is above this arc. Therefore, we need to determine the fluid above the surface, which is 1 square prism, then subtract quarter of a circle prism. Thus, our updated F sub VOA, it is equal to the specific gravity of oil times the unit weight of water, then multiply to the quantity, the area of the square, then subtract the area of the quarter circle, and multiply to the length of the cylinder. Substitute S sub O is 0.8, gamma of water as 9.81 kilonewtons per cubic meter. Area of the gross shape, that is the square, is 0.6 by 0.6 meter. For area of quarter circle, it is pi times the radius, that is 0.6 meter raised to 2, then divided by 4. And the length of the cylinder as 1.2 meter. Thus, our F sub VOA is 0.728 kilonewton downward. Update the equation with value of FVOA. Next is for FVWB, which indicates that it is below the surface. So it is equal to gamma of water times the imaginary volume. But for the imaginary volume, we need to estimate the imaginary fluid above the surface until free liquid surface of the fluid considered. So one rectangular prism, then add quarter of a circle prism. Therefore, updating now our F sub VWB, it is equal to the gamma of water times the quantity, imaginary area, rectangular area, plus the imaginary quarter of a circle area. Then multiply to length L. Substitute gamma of water as 9.81 kilonewtons per cubic meter. Area of the imaginary rectangle as 0.6 by 1.2 meter. And for the imaginary area of the quarter circle as pi times the radius, that is 0.6 meter raised to 2, then divided by 4. And length of cylinder as 1.2 meter. For FVWB, it is 11.804 kilonewtons upward. Update the equation with value of FVWB. And for FVOB, that is equal to gamma of oil times the imaginary volume. Again, for the imaginary volume, we need to estimate the imaginary fluid above the surface until free liquid surface of the fluid considered. So 1 imaginary square prism, then add imaginary quarter of a circle prism. Updating now, our F sub V O B is equal to the specific gravity of oil times the gamma of water, then times the quantity, imaginary area of the square plus imaginary area of the quarter circle, then multiply to length L. Substitute S sub O, or the specific gravity of oil, as 0.8, gamma of water 9.81 kilonewtons per cubic meter, the imaginary area of the square as 0.6 by 0.6 meter, area of, or the imaginary area of quarter circle as pi, times the radius, that is 0.6 meter raised to 2, then divided by 4. And the length of the cylinder as 1.2. Therefore, our FVOB is equal to 6.053 kilonewtons upward. Update the equation with value of F sub VOB. Then determine the value of A sub V. A sub V is equal to 7.638 kilonewtons upward. Positive, which means correct assumed direction. Okay, so that's it for the topic total pressure if fluid is above and below the curved surface. Take care and God bless.